Hello and welcome back to the channel. Today I'm going to demonstrate our network behavior analytics for Splunk app, which is a native integration for both Splunk Enterprise and Splunk Cloud. It takes a few minutes to deploy and install, and you can then generate an evaluation API key instantly within the product, which is then good and unrestricted for a 30-day period while you POC and trial the software and dig into the analytics and the classifiers and the various features that we've built into this tool. So here's the app within Splunk Base. You can log in to Splunk Base and download it as a package, which then you would upload back into your Splunk environment. Or if you're on your search head, you can then just click into Find More Apps here under the App section, and then just type in AlphaSOC into the search and pull the app down natively within Splunk itself as well. So extremely straightforward and easy to pull down. Once you have the app installed, it's going to prompt you to generate an API key. So in here you would just click the I'm an existing user and I want to generate a key box. And what's going to happen then is it's going to prompt you for a valid email address, and the backend licensing engine is then going to drop you an email with a link that you then click, and from there the API key that it generates is then completely unrestricted and good to use for a 30-day evaluation period. Now the app itself, once you have it installed, it will just come in on the left hand side like this within Splunk, and then you can just click into it and it will then generate the dashboards and give you the various tabs around settings and data location and so on and so on. So the first thing to mention is I guess the app itself, the architecture and what we're really doing at AlphaSOC. So the whole point of this app is that we're going beyond lookup tables and just very basic one-dimensional correlations within Splunk, and we're doing then 2- and 3-dimensional scoring. So things like looking at timing deltas between requests in particular domains to figure out whether they're beaconing or whether there are spikes in activity, and then interacting with all kinds of third-party APIs and services. So for every domain name that we see within a customer environment, like a destination domain name that users are browsing to, for every domain name we then who is the domain to then understand name servers, the age of the domain, registrant information, so on and so on. We correlate all of the available telemetry from our customers with Google Safe Browsing, DNS threat blocking providers, sandboxing engines, and all kinds of other third-party services. And then finally, we of course have threat intelligence and categories that we curate internally within AlphaSOC. So across those 3 layers, we're able to do all kinds of deep analytics and then flag all kinds of emerging threats that don't have signatures and identify anomalies within customer environments. So here within the architecture diagram, on the left-hand side of this diagram, we have the customer Splunk environment. So data sources, forwarders, where customers are then maybe indexing DNS logs from their domain controllers and DNS infrastructure, firewall logs, and IP kind of connectivity logs and telemetry, and then finally the third type of telemetry that we process are HTTP events. So if you have a web proxy, Zscaler or Bluecoat or whatever you may have deployed internally, and you're capturing and you have visibility into kind of egress HTTP events, we can process those as well. So if that material is all coming up into Splunk on the left-hand side and it's SIM compliant and formatted correctly, the Splunk app that we put together will then process that telemetry, ship it over to the secure enclave that we run within Google Cloud to do all that heavy lifting, correlate the telemetry with all the different third-party APIs and integrations that we have, generate and pull out all of the kind of signals and the reputation scoring. And then the alerts that we generate are then shipped back down into the Splunk environment and then rendered within the app in this kind of way, where you end up then seeing C2 callbacks, Tor circuit setup, DGA traffic, crypto mining, and so on and so on. So talking then about SIM compliant data and how the app works, we have a data locations tab that if you click into, it will then show the various detected data providers for the DNS telemetry, the IP telemetry, and the HTTP telemetry if it's available. Now, the first thing to mention here is the system will run with any one of these data sets. If you just have DNS logs coming into Splunk, we can work with those. If you just have firewall logs coming into Splunk and you don't have DNS and you don't have HTTP, we can absolutely work with those and flag events on that channel. So it's important to just mention that we do have this capability where we are able to process, IP traffic and IP events, DNS events, and then HTTP events, but we don't need all three of them to be coming into Splunk to flag anomalies. We can work with any combination of those three. So here it's detected, ISC bind material coming up into Splunk, and then on the IP side we have some NetScreen firewall material, and then on the HTTP side it's found some Nginx proxy logs as well. So the app will always try and auto detect data and look for material, and what it's looking for is SIM compliant data within Splunk. So this is then the Splunk documentation around the Common Information Model, or SIM, and the whole point of this model is to normalize material that's coming into Splunk so it can then be used by all kinds of different processes and apps inside of Splunk. So the data models that we are paying attention to and that we use within the app are the network resolution data model for DNS. So we're then looking for these particular event type tags, network resolution and DNS. And then the app is then going to look for particular fields. So it's going to be interested in the query field. It's going to be interested in record type, and then source, which is then indicating the client IP that's generating the DNS request. We then are interested in picking up network traffic, which is commonly going to be coming in from firewall logs or Bro IDS or whatever kind of full packet capture you may have. And again, you would tag those up with network and communicate event type tags within Splunk, and then you have all the various SIM compliant fields, bytes in, bytes out, source IP, source port, destination IP, destination port, so on and so on. And then finally, we use the web data model, where we can then pull out things like URL, HTTP user agent, and these kind of HTTP fields as well. So within the app itself, under data location, this will give you a sense of whether your data is SIM compliant. If the app doesn't find material under here, there are a few auto detect options that you can click into. It will present some buttons where you can run like a deep auto detect search across the various indexes. But at the end of the day, if you do run into problems here, just feel free to reach out to us, support@alphasoc.com, and we can get you certainly up and running, so long as the telemetry is coming into Splunk in the first place. So, so long as you do have firewall logs indexed within Splunk, or DNS events or Bro IDS logs, we can certainly get you up and running pretty easily. So that's basically the architecture and the way that we pick up SIM compliant data within Splunk. So the app itself, then once it is up and running, you would click into the Groups tab, and under Groups, this is where you can kind of strictly define the monitoring scope and the systems within your environment, and the network blocks and network ranges that you want to pay attention to. And so in here you can then whitelist particular destination domains. Maybe you have internal domains that you're using, particular internal IP ranges, so on and so on. You can exclude all of those and drop them out of the monitoring scope. And so that then allows you to control very clearly which material is then sent to the engine for scoring, and so on and so on. So the product itself, in terms of the groups that it ships with a group that has all kinds of RFC 1918 internal ranges in the monitoring scope. But it also, for the trusted destinations, it has all the RFC 1918 and internal private address space excluded. So the app, if you were to just take the app in a vanilla kind of fashion, drop it onto your search head, it will only then send internet-based or internet-bound events to the engine, to the AlphaSOC analytics engine for scoring, because we're primarily interested in flagging, C2 traffic, anonymized circuit setup, DNS tunneling, DGA events, and all kinds of egress events off of the environment. We're not really that concerned with internal to internal traffic, and really the whole way that we've engineered the product is to identify and kind of uncover these channels that are being set up out to the public internet. So that's just what I wanted to say around the groups and the default settings there. In here, of course, you can set up whatever arbitrary labels you want. So you can set up like guest Wi-Fi, and then under guest Wi-Fi, you would then add in the range that it was using, and so on and so on. It supports slash notation for CIDR blocks, and then asterisks here for the domains, and so on and so on. So hopefully that's relatively straightforward to follow. So the app itself, I mentioned that the analytics engine is then doing all kinds of heavy lifting. So the way that this then looks from a kind of consumer perspective is you end up with the threat hunter view, where the app is then communicating to you, these are like known C2 events. So the engine just knows that 103.68.223.150 is a nanocore rat destination, and it can flag it as such on the IP layer. And then if I click into this one, it will then flag things like, we have the C2 flag where the system recognizes that this dynamic DNS domain is a known C2. The system recognizes that this IRC server is sinkholed, so it's pointing to IP space, or it's using name servers associated with a known sinkhole, whether it's Kaspersky or Microsoft, Symantec, and so on and so on. We basically track sinkhole infrastructure. We have some more free DNS or dynamic DNS names in here. And then we have, a perplexing domain. So the system, at kind of an atomic level, the system is attaching flags to events, and it's performing all kinds of different calculations and classification of the events. So in here we have perplexing domain, which is indicating that this label within the domain name is just a kind of random looking perplexing string. We have this beacon flag, which then indicates that the timing deltas between requests to this domain are falling into a regular pattern. And then we have unreachable domain, where this domain maybe doesn't have name servers set up, or it's not accessible. So the system basically is flagging or attaching all these different flags and all these different signals to events, and then the engine, based on combinations of those signals and those flags, is then generating threats that are then being presented here within the Splunk app. Here's a sinkhole event where it just recognizes that this IP is a known sinkhole and then flags it as such. And again, the cool thing we're doing here is doing all of this within software programmatically. So it's not that we have like a blacklist necessarily, or a threat feed for a lot of this stuff. We're generating it programmatically. And then this is a good example of this, where these are all perplexing labels indicating then DGA traffic within the environment. So within a lot of other SIM products, you would need to then have a feed that does have these individual FQDNs or domain names within the feed for you to then perform a lookup against. But what we're doing here within the analytics engine is we're identifying that these are perplexing labels. They're falling into regular timing patterns with this beacon flag, and then a lot of these are unreachable domains as well, which is then indicative of DGA traffic, and something that the SOC might want to take a look at within the environment. I've mentioned Tor. We can flag Tor circuits within environments. The system recognizes that these are Tor destinations, and then we can do things like flagging events to kind of imposter domains. So this is a domain that we've set up just as like a test domain Within AlphaSOC, we have this Amazon AWS EC2.net domain, and the system on the back end has a whole dictionary of brand names that it then pays attention to. So things like Amazon AWS, Rackspace, all kinds of different like hosting providers and kind of B2B brands, Office 365, and so on and so on. And if the engine comes across a domain that's a permutation, whether it's a transposition, whether it's a Unicode homoglyph, or any kind of adjustment of a known brand, it will then flag it with this imposter flag. And then because we're whoising the domains and we're able to understand when the domains were created, we can then flag them as young or old. So if the engine runs into an imposter domain that has been registered within the last few couple of weeks, it will then generate the imposter and the young domain flag, which are then bubbled up to this traffic to a young domain impersonating a known brand threat. And this is very powerful because practically within customer environments, this then flags red team activity, state-sponsored kind of spear phishing attempts, and so on and so on. If an adversary stands up custom infrastructure that's impersonating a known brand, and the domain name is less than a month or two old, then we're going to flag it and we're going to upgrade it through this kind of logic, which is very powerful and allows you to flag kind of imposter domains. The other cool thing we're doing here is because the system is smart enough to recognize whether a domain is reachable or not, whether it has valid name servers, whether the IP actually resolves, and so on and so on. If a user was to fat finger or mistype Amazon AWS, this alert wouldn't be generated if the domain actually didn't exist. So this is just, again, another way of us generating high fidelity alerts within customer environments. The other kinds of alerts that we generate are things like known bad dynamic DNS provider traffic. So here the system has recognized that f3322.net it knows is a Chinese dynamic DNS provider domain, and then it also has recognized that this luoxk .f3322.net domain is known to sandboxing engines. So if I was to look this up, for example, on VT, it will then provide a positive series of scores where we then say, okay, these are then the latest detected files that communicate with the domain, with the malware sample hashes and so on and so on. So again, programmatically, it's not that we have this domain on a threat feed or an indicator list. The system is smart enough to recognize that this is a dynamic DNS parent domain, that the entire FQDN is then known to sandboxing engines, and there are kind of valid malware samples associated with the domain, and it then puts two and two together and then generates this high severity threat completely programmatically, which then allows you to flag emerging threats that aren't known to threat intel providers and so on and so on. And then finally in here, if I just show one of the kind of weaker signals, suspicious hosting provider traffic. So this then is a single event to a VPS / hosting provider domain. bget.ru is a Russian kind of hosting provider domain that we track. And so the system recognizes that this parent domain has been associated with other malware campaigns. Other actors have used different subdomains and different host names under this parent to register infrastructure before. And the timing deltas between requests to this domain, maybe over a few days period, has fallen into a regular pattern. So it's then attaching this beacon flag as well. And that might be something that you'd want to look at from like a threat hunting perspective as well. So that's kind of how the system is generating and kind of upgrading and downgrading the severity of threats, basically based on combinations of flags. It's then upgrading things all the way up to being critical severity, or leaving things maybe at low. If it's like a single event, it will come in as a low, but it gives you then that sensitivity by which if you do have a clean and kind of reasonably secure and assured environment, you will then be looking at this in such a way that it will be generating, let's say, a handful of mediums and lows each day, which are very, very weak signals. And maybe one of those would be an anomaly that's actually interesting and allows you to kind of threat hunt around that. So yeah, again, the whole point of the system is, we generate these very high fidelity signals around, clear infections and things that are clearly, worth looking at from a threat hunting perspective. DNS tunneling, DGA events, traffic to sinkholes, HTTP post operations to known kind of bad destinations. So in here we have the DNS block flag and then the sandbox flag. So DNS block is indicating that the different DNS blocking providers, Quad9 and 1.1.1.1 and the others that do DNS threat blocking, they are blocking access to this domain, which we then find interesting. That's an interesting signal that we can use and communicate to our customers. And then we also have the sandbox flag in here. And again, if I open this up in VT, this will then show me, the associated threats with this domain that are known to VirusTotal as well. So hopefully that gives you a quick overview and an idea of, how easy it is to get up and running with the product and dig into threats and events and so on and so on. The final thing I'll mention is I'll click into the documentation and show you the raw alert format. The reason I'm doing this is we actually have under here a kind of an exhaustive list of all of the the various flags that we generate. So in here you have things like C2, crypto mining, crypto jacking, dropper domains associated with malware distribution, known VPS and hosting provider domains, perplexing domains, perplexing hosts, Google safe browsing, destinations that are known to safe browsing, Tor destinations, young domains, third-party VPN infrastructure, and so on and so on. Now, some of these actually we generate events under the policy violations view. And let me, I guess, finish off with this other tab. So we have the threat hunter view, which is supposed to be used by security operations and threat hunting folks. It's going to give you a good idea of anomalies and emerging threats and known issues within the environment. The policy violations view contains events that are less severe. So a problem that we ran into in the early days of AlphaSOC and that we've seen security teams struggling with over recent years is separating out potentially unwanted programs and kind of like pups from severe malicious malware outbreaks and samples within an environment. Now, especially if you have, let's say, a large estate with 10, 20,000 systems, a lot of security tooling, Palo Alto Networks firewalls and other apparatus have a hard time differentiating between pups and kind of full-blown kind of malware samples and families. So what we've done within AlphaSOC is we've done a lot of work to categorize unwanted programs in particular. So here we recognize that Ola is an unwanted browser extension, and we flag it with this unwanted flag. We then have this other domain here, stat.function.net, is recognized as an unwanted program domain, epicunitscan.info, and so on and so on. So the value here and the real beauty of what we've been able to do with this categorization is we take all of these pups and these less severe events and we can throw them off into the policy violations tab, which then means that the security team is then able to just focus on anomalies and clear severe events that require attention. And then these policy violations, a lot of our customers will then drop them into ServiceNow or ticketing systems for their IT operations to deal with without the security team. In here we have third-party VPN activity. So this is Hotspot Shield, I believe. And then this is another VPN provider domain, third-party VPN provider domain. We can flag things like TeamViewer and remote access software. So within your environment, if let's say you don't allow TeamViewer and you want everybody to be using RDP, we can then, of course, flag TeamViewer as a policy violation and have the IT operations team dealing with that as well. And this is something we've seen actually from a kind of adversary perspective as well. We have seen TeamViewer used in recent months and years within environments to evade detection and so on and so on. So hopefully that gives you an idea of the kind of the differences between the threat hunter view and the policy violations view, and the ways that these events can be consumed. Finally, if I click into settings, in here we then have the kind of different checkboxes around escalating events up into Splunk ES and alerts up into Splunk ES, escalating alerts to third-party services. So in here, you could then escalate your policy violation events off to ServiceNow or Alien Vault or or another SIM or SOAR platform like Phantom or Demisto very easily. And you can also actually in here elect to use on-prem processing. So in here, you would then deploy the AlphaSOC analytics engine locally within your environment, and it's as easy as then just pointing the Splunk app at the on-prem instance in here. I would say 95% of our customers use the cloud service that we operate, and it's relatively straightforward for us to provision kind of on-prem VM instances as well, and get folks running up in that way, up and running in that way as well. So feel free to reach out to us if you do want to discuss on-prem deployment. But hopefully that's given you an idea of the capability, the deep analytics that we're providing, whether it's flagging, beaconing to young domains that within suspicious TLDs, traffic to dynamic DNS providers, traffic to known, bad VPS and hosting providers, Tor circuits, DGAs, all kinds of, different use cases and traffic types that we're able to flag. Finally, I'll just mention licensing. So in here, the Splunk app will track over a 30-day period the number of unique endpoints that it sees within the environment, and then we basically license by taking the average, the 90th percentile average of this, and then we then put together annual term licensing. And within our documentation, we have the pricing bands. You can click into the documentation here, and it breaks down. The pricing goes from $8 per endpoint per year, all the way down to 75 cents, depending on the number of endpoints that we're then covering within, with the analytics and the visibility itself. So that's what I wanted to wrap up with. Hopefully you found that useful. Feel free to reach out to us directly if you do have any questions, and I look forward to catching up with you soon. All right, thanks a lot, guys. Bye.